The chapter is Quadrilaterals for standard 9. The question is, if the diagonal of a parallelogram bisects one of the angles of the parallelogram, it also bisects the second angle. That means it is given a parallelogram. So ABCD is a parallelogram, and AC bisects, the diagonal bisects one of the angles. So we will assume AC bisects angle A. That means bisecting means dividing the angle into two equal parts. So this angle, let's name this as 1 and 2. It is given angle 1 equal to angle 2. So that is angle 1 is equal to angle 2. Now we have to prove this will bisects angle C also. That means angle 3 and 4 will give the name as 3 and 4. So we have to prove angle 3 is equal to angle 4, and ABCD is also a rhombus. Yeah, it's given now. ABCD is a rhombus, parallelogram, and 1 equal to 2 is given. Now since this is a parallelogram, 2 is equal to 3 and 1 is equal to 4. So we will write this as angle 2 equal to angle 3. The reason is ABCD is a parallelogram. AB is parallel to CD, alternate angles. Now we know 1 is equal to 2. It is given. And we also have 1 is equal to 2 equal to 3 and 1 is equal to 4. We also have 1 equal to 4. The reason is here AD is parallel to BC. AD is parallel to BC, alternate interior angles. Now if you see from these, 2 equal to 3, 1 equal to 2, 1 equal to 4. So we can, from these we can write from angle 2 is equal to angle 4, from 2 and 3, and we have 2 is equal to 3. Angle 2 is equal to 3. Therefore, and angle 2 equal to 4, that means angle 3 is equal to angle 4. So if 3 is equal to 4, that means AC, therefore AC bisects angle C. Now we have to prove it is a rhombus. So it's already a parallelogram. So we have to simply prove the adjacent sides are equal. Then it is a parallelogram. So now if you see angle 2 equal to angle 4. So now 2 is equal to 4. Then you can say AB is equal to BC. Angle 2 equal to angle 4. You can write AB, it's an isosceles angle property. Opposite sides of equal angles are equal. So AB is equal to BC, isosceles triangle property. So therefore ABCD is a rhombus. Reason is adjacent sides of a parallelogram are equal. So you can say the ABCD is a rhombus. this is already given. ABCD is a parallelogram. AN and CP are perpendiculars. AN and CP are perpendiculars. Prove that ADN is equal to triangle CBP. So ADN, so this triangle and CBP, these two triangles are congruent, we have to prove. So if you see, this is a parallelogram. So AD is equal to BC. We already, it's given AP, AN is and CP are perpendicular. So they are 90. Now we have one more, we can take, these two angles are equal. ADB and CBD are equal because AD and BC are parallel. So we'll write it down. So AS, we can say these two triangles are congruent. So consider triangle AND and triangle CPB. So we can say AND, angle AND is equal to angle CPB. Angle is given AN, it's, you can write simply, it's given, and angle, I'll give this angle as 1 and angle 2. So angle 1 is equal to angle 2. The reason, AD is parallel to BC. Alternate angles are equal. Alternate interior angles are equal. Now we have AD is equal to BC side. The reason is AD is parallel to BC. ABCD is a parallelogram. Therefore, you can say triangle AND is congruent to. So AND is congruent to. So we have to write CPB. Triangle CPB. The reason is AS congruence. From that you can say AN is equal to CP. Therefore, AN is equal to CP, CPCT. Congruent parts of congruent triangles. So you got both the results. So ABCD is a parallelogram. Angle DAB is equal to 60 degrees and it's given AP and BP are angle bisectors. And prove that, you have to prove P is the midpoint of CD. So these two are, DP is equal to CP is what you have to prove. So AP and BP are angle bisectors. It is given DAB is equal to 60. Then this full thing is 60. So you can write this as 30 degrees, and now this is a parallelogram. So you can find this angle D. So I'll write angle DAP is equal to 30 degrees. The reason is AP is angle bisector. Now angle DAB and angle D are co-interior angles. Angle D plus angle A is equal to 180 co-interior angles. AB is parallel to CD. Now, therefore, angle D is equal to 180 minus, it is given DAB is equal to 60. So that is equal to 120. So we have this angle as 120. So from this we will get this angle. So angle 1. So angle 1 is equal to 180 minus 120 plus 30. Angle sum property. So you get 150, 180 minus 150 is equal to 30. So angle 1 is equal to 30. Now this angle is also 30, this is 30. From that you can say angle AD is equal to DP. Reason is isosceles angle property. Angle 1 equal to angle DAP. Similarly, we can prove, again here also we can prove the same. Here this angle will be, see, if you see, this is 120, so this angle will be, angle C will be, angle C is equal to 180 minus 120 is equal to 60 degrees. The reason is AD is parallel to BC. So we got this as 60. And this angle, if you see again, this is 60, the total is 60. So this will be the 180 minus 60, 120. So similar angle ABC is equal to 180 minus angle DAB, that is equal to 180 minus 60 is equal to 120. Again, co-interior angles are supplementary. So from that you will get angle ABC is equal to 120, and again it is given BP is angle bisector. So 120 by 2, so this angle 2. So angle 2 is equal to 120 by 2 is equal to 60 degrees. Is given BP is angle bisector. And this is 60, this is 60, so this also will be angle BPC. Therefore angle BPC is equal to 60 degrees. So from that you can say this and this are 60 degrees, so BC is equal to CP. Now if you see, AD is equal to DP, BC is equal to CP. We also know AD is equal to BC. So we will write it down again. AD is equal to DP, BC is equal to CP, and AD equal to BC. So from this we can write AD equal to BC is opposite sides of parallelogram. From this you can write DP is equal to CP. Because AD equal to DP, BC equal to CP, AD equal to BC. So DP equal to CP. So DP equal to PC means P is a midpoint.